Hello to everyone guys, Raymond is back again in this tutorial, and so today I have come with another video. So today we will discuss about the product of matrices. In the previous video actually something was missing, and so actually this PDF was not included in the drive folder, so I have to stop that video on that point. But today we have with this video with the product of matrices. So now we will look upon this product of matrices in some seconds. Okay, so first of all, subscribe this channel and give one like. And if you want to be a machine learning engineer, data scientist, and a good computer science student, then I think you should be consistent in this YouTube channel. And so watch all the videos again and again, and also share its link to the peoples who are same as you. So now let's start the session. So this is just the product of matrices. So here actually in the previous video we have talked about the additive identity for the matrices. And so 0 will be the additive identity for any types of matrices, whatever the matrix is, that is a scalar matrix, that is a null matrix, or everything else. So actually that's doesn't matter. We have already seen that what is a additive identity of matrix. Now let's talk on this point. So this says that the null matrix 0 of the m cross n acts as the identity for addition in the set of all m cross n matrices. This point says that the null matrix O, this is the null matrix O. So this will be the m cross n. Actually I think I think uh, this is a null matrix. Okay, and so null matrix is such a type of matrix in which there are all the elements equals to 0. So a matrix which have its all elements equal to 0 is known as null matrix. And suppose and think that remember this, that the null matrix be of any order. It's be of m cross n. So m will be the number of rows and n will be the number of columns. And so here O is the null matrix, and this null matrix have its all element equal to zeros. Okay, so this null matrix of the order m cross n acts as the identity for addition in the set of all m cross n matrices. So in the previous section we have seen that the additive identity for any type of matrices is 0. Okay, so actually just 0 is a null matrix. Okay, 0 is a null matrix. So there we have seen that a plus 0 is what a plus 0 is equals to a. So in the previous section, actually if you don't mind, then you can watch that video again. You can watch that video again in the last timing, in the last interval. There you will be there you will look that what is the additive identity. Okay, so there we have seen that uh, a plus 0 is equals to a. That is, additive identity is such a type of term or the element when we add this term with any of the matrix, then we get that matrix itself. Like as when we add 0 to the matrix A, then we get matrix A itself. So what about that 0? What was that 0? Is that 0 a scalar quantity? Is that 0 a scalar number, or is that pure 0? So what about that 0? So actually 0 is not a numeral, 0 is not a digit, 0 is not a number, 0 is not a scalar quantity, but there 0 was the null matrix. Okay, 0 was the null matrix, and so this is denoted as O. This is O or 0. not 0, I think O. So the null matrix is denoted by O, and there A plus O is equal to A, and so there O is the null matrix of order m cross n. So what we have to look here. The null matrix O of the m cross n acts as identity for addition in the set of all m cross n matrices. If we have any matrix of order m cross n, then the null matrix O of the order m cross n will be the additive identity for each and every matrix. Now come to next point. So this is the additive inverse. So what about this additive inverse? So let's read its definition. Let A is equals to the matrix Aij be a matrix of order m cross n. Then the negative of the matrix A is defined as matrix minus Aij and is denoted by minus A. So this is another term. This was additive identity and this is additive inverse. So let's see what it says. This says that A is a matrix of order m cross n, and here the negative of the matrix A is defined as matrix these. So this is A and its negative is this. Okay, this is the matrix A and this is the negative of matrix A, that is minus A, and so the negative of matrix A will be denoted by minus A. So A is this and minus A is this. Then there is a relation and the relation is defined as this. So this is the relation between the matrix A and the negative of matrix A. And what about this relation? This relation says that when we add these two such that A matrix and negative of A matrix, then we get what? Then we get 0. Is this 0? Is this a scalar 0? Is this a number 0? No, it's not 0. It's not a scalar quantity. Then what about this? So this 0 is a null matrix. Okay, and actually I have not discussed about null matrix in previous videos, because actually we all have come across after studying in some lower classes, and there in the topics of matrices we have learned about the null matrix. And so actually I don't think you are so ignorant that you don't know about the null matrix. So if you want to know something more about null matrix, then I will make a separate video on null matrix. Okay, so after this video I will make a separate video for uh, explaining about what is the null matrix. But uh, look here, this is the relation. So so what this relation says? This relation says the addition of A matrix A and the negative of matrix A, and this relation is equals to O. This O is null matrix, and if A is of order m cross n, then its negative will also be the same order, so its order also will be m cross n. So the sum of two m cross n matrices will be equals to also a matrix of order m cross n. So this is a matrix, this is not a scalar quantity, this is not a number, this is a matrix. This O is a matrix and it's a null matrix. Okay, and this matrix have its order similar to these matrices. Okay, so the order of these matrices are m cross n, so m cross n will be the order of this matrix too. Okay, so this is the additive inverse. Actually, look in this way. Additive inverse is just a term. Additive inverse is just a term when we add the additive inverse of a number to itself, then what it gives? Then it gives 0. So suppose actually we have to find the additive inverse for 2. Suppose we have to find the additive inverse of 2, then what we do? So for actually the additive inverse is a term, and we have to add the given number and its additive inverse, and then this will give 0. So what will be that number? So the additive inverse will be minus 2. The additive inverse will be minus 2. Therefore 2 is the given number and its additive inverse will be minus 2. So 2 plus minus 2 will be 0. So one, the first is the given number, and the second quantity, that is the additive inverse, is just its negative, just the negative of the given number. And so when we add these two quantities, its sum will be equals to 0. So the additive inverse is just a number, or just a term, or just a matrix. In the case of matrix, it's a matrix which is the negative of the given matrix. Actually, this is the chapter related to matrix, so in this case we will not talk about numbers, numerals, digits, and anything other else. We should always talk about matrices. So A is the given matrix, and the additive inverse is the negative of this given matrix. Okay, so additive inverse is the negative of this given matrix, and when we add these two matrices, this its sum will be equals to a null matrix of the same order. Okay, so if you have any query regarding this additive inverse, then you can message me. My telegram number or my WhatsApp number is given in the description, so you can contact me there. So now there is one more law, cancellation laws. So what about these cancellation laws? If ABC are M cross N matrices, then what? So these cancellation laws says that there are three types of matrices, A, B, and C. So A, B, C are matrices, three matrices of order M cross N. Then there are two laws. What this law says: A plus C will be B. Sorry, A plus C equals B plus C. So this is a relation. This is a relation. A plus C is equals to B plus C. So this relation implies that A is equals to B. Hmm. So this law is known as right cancellation law. Cancellation law means that we have to cancel some equal terms. So C is also present here and C is also present here. So when we do some calculations, when we do some equivalences, then actually this C will be cancelled by this C. So then what we obtain? So after cancellation of this C, we just obtain A in the LHS and B in the RHS. So just we get A equals to B. So this is known as right cancellation law, because C is in the right hand side of this quantity and this quantity. So and also we are cancelling the right terms. This is the right term of LHS, and this is also the right term of RHS. So in this law we are cancelling the right terms. So C is cancelling here, and so we are we are getting A equals to B. Now coming to the next point, this is left cancellation law. This says that if C plus A equals C plus B, then A equals to B. So this says here C is common, so we cancel C, then A will be equals to B. So this is the left cancellation law, and it's right cancellation law. So it's not so difficult, it's very easier to understand. Now coming to the next point, this is the commutative law holds for. This point says that commutative law holds for scalar multiplication. So this says that what about commutative law? So in the previous videos we have studied about the commutative law for addition, and so there we can write A plus B equals to B plus A. That means according to commutative law we can change the order of we can change the we can just change the order of we can just change the order of terms and something other else. And so um, according to this cancellation, sorry, not cancellation, according to this commutative law, we also apply this law for addition and also for multiplication. Okay, so here is the case of multiplication, not for addition. So for multiplication we should see that what this law says. So here this says that if we multiply a scalar quantity, this k is a scalar quantity, so k is multiplied to a, so k into a will be a into k. Okay, k multiplied by a equals a multiplied by k. So we can change the order of terms. Just a is the given matrix and k is the scalar quantity, so we can change its order. So just commutative law says about changing the order of terms. Then there are distributive laws. So these two are distributive law. This is known as left distributivity and this is known as right distributivity. So this says that a plus a and b are two given matrices, and so k is a scalar quantity, so k is multiplied to both a and b. So what it happens, this happens k into a, k multiplied by a plus k multiplied by b, and this is the case of right distributivity. So in this case a plus b, the sum of a plus b will be multiplied with this scalar quantity k. So a will be multiplied with k and plus b will be multiplied with k. So these are just the relations. You can just remember these things. These are not so much difficult for understand. These are very easier. Now then, come here. This is the new term, this is the new case. This is product of matrices a and b. So there are two matrices, a matrix and b matrix. So here we have to know about what is the product of two matrices. So let's read this definition. Two matrices A and B are said to be conformable for product AB if and only if the number of columns of A is equal to the number of rows of B. So actually, what is about this condition for conformable? So this conformable condition comes for the addition, subtraction for the matrices and also for the multiplication of matrices. Okay, so what it says, in the case of addition and subtraction, we just have to see one thing, that the order of the matrices should be same, should be equal, and then we can say that two matrices are conformable for addition or subtraction, right? But here in this case, this is the case of multiplication, and so here we can there is some another case here. It is something another condition for checking the conformability of two matrices for multiplication. So just look here. This says that two matrices A and B are said to be conformable for product AB. That means A and B are conformable for multiplication, that we can't multiply two matrices. We always cannot multiply two matrices. If we have to multiply any two matrices, any two given matrices A and B, then we have to just satisfy one condition. And what is the condition? That condition is to be ensured that these matrices are conformable for product or not. Are these matrices conformable for multiplication or not? So if these matrices are conformable for for multiplication, then we can multiply these two matrices and then we will go to the product AB. So this is the product AB, that is the multiplication of A and B matrices. So here this says that what is the condition? So the condition is if and only if the number of columns of A is equal to the number of rows of B. That means the number of columns of A. Suppose A is a matrix, A is a matrix and B is also a matrix. So suppose that A has A is a M cross N matrix. The order of A matrix is M cross N, and suppose the order of B matrix is P cross Q. Okay. So this says that if the number of columns of A is equal to the number of rows of B, that means there should be similar number of columns in A and also the similar number of rows in B. This says that if there is if A is the matrix of order M cross N, then this matrix A has m number of rows and n number of columns, right? So n number of columns, and so according to this condition, this is equal to the number of columns of A is equal to the number of rows of B. So and suppose the B matrix is of order what? P cross Q. We have suppose it P cross Q. So P is the number of rows and Q is the number of columns. So here we will do one thing, that the number of columns, that is the n, and number of rows of b, that is p. So this n and p will be equal. So just remember this condition, that the number of columns of a is equal to the number of rows of b. If this condition will be satisfied by these two matrices, then we can find the product of two matrices, two given matrices. Otherwise the multiply will not exist. We can't multiply always the product, sorry, two given matrices. So if we have to multiply two matrices, then we have to satisfy this condition. Okay, and now here look one thing, when we add two matrices, then their sum is also a matrix. When we find the difference between two matrices, that means a minus b, then their difference is also a matrix. So in this case of multiplication, if a and b are two matrices, then ab is also a matrix. Its product, their product ab is also a matrix. Now coming to next point, two matrices A and B are said to be conformable for product BA if and only if the number of columns of B is equal to the number of rows of A. So this is the another case. This is the another point. So uh, you have to understand this very deeply. Actually, when we write ab and ba, actually ab and ba are not equal. In the case of matrices, when we multiply these two matrices a and b, then what we get, we get the product ab will be the product. So recall algebra. You have studied algebra in the previous classes in your 10th standard or in your 12th standard. So there in the whole algebra, you have studied that when you multiply two terms, a term and b term, then we will get what, we will get its product, and that is ab. And so we can also write this ab as ba. Actually ab is write as ba. And so please look here, actually this is the commutative law na? This is, so what this law says, this law says that when we multiply these two quantities, first is this is the first quantity and this is the second quantity. So when we multiply these two quantities, then this we can change the order. So according to this commutative law, we can write k into a will be a into k. But if k is also a matrix, a is here a matrix. But if k is also a matrix, then we cannot write that this will be equals to this. We cannot write, because this is another matrix and this is another matrix. These both will be different matrices. So look here, this is here we are multiplying two matrices a and b. So a and b are what, a and b matrices will be multiplied and they will give the product ab, and also they can give b and a, sorry ba. It's reverse order ba. But the ab matrix, and here this is the ba matrix, this is also the product of a and b matrix. But this product ab and this product ba are not equal. They are never equal, never. And if they are equal, then it's an exception, but they are never equal, because this ab and this ba are not equal, never equal. Okay. And also in this case, please remember one thing, that commutative law doesn't hold for this, that ab is not equals to ba. This is another matrix, this is a different matrix. Okay. And so if we have to find the ba, then what to do, then we have to another condition for checking the conformability of the matrices, that two matrices a and b are said to be conformable for product ba if and only if the number of columns of b is equal to the number of rows of a. Okay, so a and b will be conformable for product ba if the number of columns of b is equal to number of rows of a. That's, so this is another condition, this is another condition. So in this condition, first we write the matrix a, then we write the matrix b, and then we multiply. And after the multiplication process, we will get this product AB. And in this case the matrices A and B are multiplied. If they are conformable by this condition, then first of all we write the B matrix, not A matrix. First of all we write B matrix, then we write A matrix, and then we will do the process of multiplication, and then we get the product BA. So this is the product AB and this is the product BA, and so both are different matrices, not same. Now come to the next point. If you have any doubt or any confusion or any query in these things, then you can message me directly. Actually just uh, I am not giving examples and something else, but I will make a separate video on how to find the product of matrices, how to find the product of different types of matrices. I will make a separate video, but here actually just understand these things with notes, with the help of notes. Actually if you are good in mathematics, and if you have studied these things in your previous classes, then I think it's not essential to understand by giving examples and showing you uh, some things, some calculations or some things, some derivations and some things with the help of board and marker. So actually I don't think these things are also you have studied these all things in your previous classes. So just I am using these notes for but if you have any problem, then please you can comment in the comment section, and so I will make a separate video for these things. Okay, now coming to the next point, the this is a definition, and what this says: the product of two matrices is defined if and only if the number of columns of prefactor is the same as the number of rows of postfactor. So what this says, wait 1 minute. Yeah, nothing. Okay, so what this definition says? This definition says that this definition defines about the product of two matrices. Okay, so suppose that there are two matrices, A matrix and B matrix, A matrix and B matrix, and we have to find the product of these two matrices, and we know that the product of two matrices will be AB. Okay, so A into B will be AB. A into B will be equals to AB. Okay, so this says that the product of two matrices is defined if and only if always this is not the case that always this product will be defined, but this product will defined only if the number of columns of prefactor is the same as the number of rows of postfactor. So suppose here, what is prefactor and what is postfactor? Actually you know about matrices, you know about the rows, you know about the columns. hmm? So you are not so ignorant that you don't know these things, but here are some two new terms, prefactor and postfactor. So what about this prefactor and postfactor? So suppose that this is AB, this is written as this is AB. So when we have to multiply two matrix, and suppose the first is A matrix and second is B matrix, suppose first is A matrix and second is B matrix, then what to do? So in this case what will happen when we multiply this? We will write A cross B will be equals to AB. So in this case A will be the prefactor, because first of all we write A matrix, and then by writing the cross sign or the sign for multiplication, then we write the B matrix. Okay, that is the first matrix or the second matrix, and in between of these two matrices we write the sign of multiplication. So the first matrix will be known as the prefactor and the second matrix will be known as the postfactor. Okay, so what this definition says? This definition says that the product of two matrices will be defined if and only if the number of columns of prefactor, that means the number of columns of the first matrix, is the same as the number of rows of postfactor, that means the number of rows of this second matrix. So actually this condition is not different, this is nothing different. Actually this condition is just uh, just as the upper condition. So this condition, sorry, this condition is equal to this condition. Okay, this condition. So actually this condition is known as the conformability, checking the conformability for two matrices for multiplication. So just we have to check that if these two matrices are conformable or not, and if they are conformable, then we have to check this conformability with this condition, and then we can find this product. Okay, now come to the next point. This says that if A is a M cross N matrix and B or N cross P matrix, then AB will be a M cross P matrix. Suppose A is a M cross N matrix. The order of A matrix is M cross N, and the order of B matrix is what? N cross P. So when we have to find the product AB, suppose these two matrices are conformable for what? Conformable for product, right? Then we get, after the process of multiplication, we have get this product AB. So this says that if the order of A is M cross N and order of B is N cross P. So look here one thing, N is the number of columns of A and N is the number of rows of B. So this is satisfying the condition for checking the conformability for the multiplication of two matrices. So this is what? This is satisfying the condition, this condition, and so we can say that here the product will be exist and the product will be defined, and so this is the product AB, and so this says that the order of AB will be M cross P. That means AB have number of rows equal to matrix A and the number of columns equals to the matrix B. So just remember this thing. This is a very good concept. Now let's come on the next point. This says that let A will be this be a M cross N matrix and B will be Bij be a N cross P matrix. Then the product of A and B will be defined as the matrix this Cik. Okay, where Cik will be this. So actually this says that how to find the product of two matrices. Till I have explained about what is the product of matrix, how to check the conformability of two matrices, and what are the conditions for checking the conformability, and what will be the order of the product AB. But actually till now we have don't know that how to find the product, what will be the product, how to define the product. So we don't know anything. So this is the process, this is a point that will tell about how to find the product AB. Okay, so suppose that A is a matrix and B is the matrix. Okay, so this A and B are two given matrices, and suppose that this is the order of first matrix and this is the order of second matrix. Okay, so now it says that the product of A and B will be defined as the matrix. So here we have taken some another matrix, that is Cik. Okay, Cik. So this matrix will be defined as this summation j will be equals to 1 and its maximum limit will be n. This is the sign of summation. So j is what? J is a variable, so j will vary. I and k are fixed, but j will vary. So j has values from 1 to n. The values of j will varies from 1 to n, and so Cik, the matrix, this matrix will be equals to the summation j equals to 1 goes to n, and this, what is this? This is Aij Bjk. That means this is the product, this is product of two number. This is the first number and this is the second number. So the first number is Aij, means that what? This term means that this is the element, that exists in ith row of A matrix. I means ith row and j means jth column. Okay, so actually Aij is, what is Aij? Aij is an element of ith row and jth column of matrix A. And what about this term? This term says that this is an element of jth row and kth what? Kth column of this matrix B. Okay, so just we have, don't do anything, we have to multiply the correspondent what correspondent terms. Okay, the correspondent terms of one row and the column of the second matrix. Actually, this formula goes to, when we expand this term, this will goes to this a I 1 b 1 k plus this. Okay, so how this product will be find, how this product will be obtained. So actually, whenever we don't look something with process, we don't know about this. Okay, so for knowing the process, I will make a separate video, and there I will show that how to find the product of two matrices. So what is the uh, real method, what is the correct method for finding its product. So now, bye for now. And quickly I will bring the next video, and in the next video I will show you, I will explain you that mm, what is the product and how it defines, and how to find the product of these two matrices. So bye for now. So don't forget to subscribe this channel if you want to be a machine learning engineer or a data scientist, or you are preparing for GATE CS exam or GATE maths exam, then please subscribe this channel. So now bye.